Hello, in this video I'm going to solve the following problem for you. Evaluate the following definite integral. Integral from 1 over square root of 3 to square root of 3 of dx over 1 plus x squared times 1 plus x to the power of 2024. That would be a good idea if you pause the video at this point and try to solve the problem yourself first. If you couldn't solve the problem in the first attempt, in the next slide I will provide you with a hint. The hint is as follows. Call the integral I and introduce the new variable capital X as follows. That would be a good idea if you pause the video at this point again and try to solve the problem yourself using the hint. If you do your calculations correctly, the answer to this definite integral is pi over 12. Okay, now let us solve the problem. So I called the integral I, and as given in the hint, I want to introduce a new variable capital X as 1 over x. Okay, so then what should I do? I have to rewrite my integral in terms of the new variable x. So I have to get rid of all appearances of the old variable little x. So to do that, I will actually find little x from here is 1 over x. Then I calculate dx. So dx becomes minus 1 over capital X squared d capital X. And of course, if little x goes from 1 over square root of 3 to square root of 3, because capital X is the reciprocal of the little x, this would then imply that the capital X goes from square root of 3 to 1 over square root of 3. Okay, so the integral I can also be viewed in this form. It goes from square root of 3 to 1 over square root of 3. Instead of d of x, I can write minus 1 over capital X squared d capital X, and then divided by 1 plus little x squared becomes 1 over capital X squared, and the other one becomes 1 plus 1 over capital X to the power of 2024. Yes? Okay, so I do simplifications now. I will use this minus sign to flip these two limits. So the limits will be the same as before. So let me just do that. It becomes integral from 1 over square root of 3 to square root of 3 without any minus signs. And then what I do, I will rescale this fraction by x squared, meaning that I multiply the numerator and the denominator by x squared. If I multiply the numerator by x squared, then I will have only dx left. And if I multiply the denominator by x squared, I have two options. I can either multiply x squared here or there, but I will prefer to multiply it here. So then this 1 becomes capital X squared, and this becomes simply 1. And then what I do in the second factor, I take the common denominator, which is x to the power of capital X. Capital X to the power of 2024, then I will have x to the power of 2024 plus 1. And now what I do, this will go into the numerator. So finally, I will get that the integral I can also be written in this new form. Okay, so and if you don't mind, instead of writing x squared plus 1, I just write 1 plus x squared, and I will do the same thing in the second factor because this has gone to the numerator, this is left. I flip it to write it in the very similar to the original form of the integral. Okay, but you know that variables in definite integrals are dummy variables. So what does it mean? It means that I can rename this variable everywhere, and the result of the integral will not change. So I call capital X to be little x again. So I just want to know that It doesn't mean that the little x and capital X's are equal, but it means that I convince you that the integral I that we have is also equal to this integral. And in this integral, it doesn't matter which name I choose for my variable. I now choose the same old variable as little x. And then I will have x to the power of 2024 dx, and the denominator is simply 1 plus x squared multiplied by 1 plus x to the power of 2024. Okay, so this is also the I. Okay, on the one hand, I is this. On the other hand, I is this. So if I add these two relations side by side, then I will get I plus I equals 2. I can just combine these two integrals because both of them are integrals with the same limits, as you see. So what I can do, I can write the numerator. I can add the integrands, yes? This is the integrand of the second integral, yes, plus the integrand of the first integral. And the whole thing dx. And of course the limits are the same. Okay, but now on the left side, I plus I is nothing except 2i, but now something very interesting happens, you know. The denominators are the same, so I have to add the numerators. But when I add the numerators, it becomes 1 plus x to the power of 2024, which will cancel this term in the common denominator. So I will be left with integral from 1 over square root of 3 to square root of 3, 1 over 1 plus x squared dx. But that's also very famous because this becomes arctangent of x from 1 over a square root of 3 to a square root of 3. So it becomes arctangent of square root of 3 minus arctangent of 1 over a square root of 3, but arctangent of square root of 3 is pi over 3, the other one is pi over 6. So when I subtract them, it becomes pi over 6. But be careful, this is not your I, this is double of your I. So your I is this number divided by 2, or in other words, I is equal to pi over 12. Yes, so and that is the answer that we are supposed to reach at. If you found the video useful, I would appreciate considering to subscribe to my channel and like the video. Until the next video, be safe and goodbye. Thank you.